In this tutorial, we will see how to manage the self-consumption part and the financial part. To access the next two steps, you just need to activate self-consumption and financing with a tick. Let's open the self-consumption tab. On this page, we define the load profile of the building, and therefore consumption, in the most precise way possible. We have several ways to enter consumption. We can enter it annually, not divided into ranges, annually divided into ranges, or to be even more precise, monthly, divided into ranges. It is also possible, if we have hourly consumption data, to upload the profile in CSV format within inSun. Here we have some tick boxes, relating to household appliances, and the various daily habits in the home. We can select the number of people, and the type of lighting present. For this example, we are going to enter an annual consumption, divided into ranges. For example, let's set as F1 value, 90,000, F2, 30,000, and F3, still 30,000. Click on Reload Graph. Down here, we can see the production line of the plant in fuchsia, and in blue, instead, the load profile of the building, or rather the daily consumption, developed precisely over the 24 hours of the day. We are also shown some production graphs. In this case, we have almost 58% of self-consumption, and 42% of the energy we feed into the grid. The second graph is the same, but on the energy consumed and not on that produced. What we see is an annual average, but we can also interrogate the graph in the individual months. For example, in January, consumption is higher than production, and therefore we have almost 100% self-consumption. We observe July instead. We see that production exceeds consumption, so we will feed 34% of the energy produced into the grid. We can choose which of these graphics to print in the final document by activating the tick, Print in Document. Once we have defined the load profile in the consumption graph, we can move on to the financial section. First of all, we can set the duration of the economic analysis, and the currency with which we want to work. In the first part, we are going to define the cost of the photovoltaic system, in euros per kilowatt peak. In this case we have a system of almost 100 kilowatts. We can keep 1,000 euros per kilowatt. Annual cost refers to maintenance costs, such as the cleaning of the modules. We can hypothesize 500 euro. Annual decay of the modulo power as a percentage. The cost of the battery, it is used only in systems with storage. This is not the case in the example, and therefore we leave both the cost of the battery and the percentage of decay at 0. In financing, we are going to define the parameters of the financing and the type of any grants to which we have access. For example, on an annual basis we could set 50% in concession for 10 years. As regards the basic prices, it is necessary to define the purchase price of the energy. Usually, it is around 0.2 euros for residential properties. The selling price of electricity is the revenue derived from the energy we feed into the grid. We can insert an annual increase in energy prices for a more accurate analysis. Incentive rate refers to the incentive that was recognized on all the energy produced. Being no longer in vogue, it corresponds to 0. We can recalculate the graph, and at this point we have the repayment plan. We see that the first year we have an investment initial amount of almost 100,000 euros, which is immediately amortized by the incentive, and by the energy production of the first year. We see that the investment is already returning to the fifth year. We are in fact just above the 0 line, with about 1,000 euros. We have a final yield, at the end of the 20 years, of 238,000 euros. This is a very important datum. The annual rate of return actually makes us understand whether our plant, combined with consumption and incentives, is performing sufficiently or not. Once we have finished the return plan, we can save the file in PDF format. This will now be saved on the inSun cloud. The PDF we are exporting will contain all the graphs we have analyzed. In the printout there are the tables relating to each individual inverter. And, finally, the new graphs relating to self-consumption and to the repayment plan.